The temperature is set to 0.2. Temperature controls the randomness of the model's output. Lower values make responses more deterministic and focused, while higher values make them more creative and diverse. Setting it helps balance precision and creativity depending on the needs of the application. Then we hit another issue. Hello everyone, welcome on Debugging with K Tips. If this isn't your first time here, then welcome back. If it is your first time, welcome on board. We begin day 2 of our challenge on building an AI agent application in 7 days. From scratch. The goal is to use as few frameworks as possible, focusing instead on pure Python coding. This way we will truly understand the frameworks and their advantages. We have a lot on our 7-day agenda. By now, we've completed day 1. We built the entry point of the application where users can provide their inputs. We trained a Keras model to classify user inputs. This application is designed to only handle texts related to content creation on a social media platform. So when a user sends something unrelated, the process is interrupted, and they immediately receive a message saying the content is irrelevant. But when a user sends an interesting text, we use it to keep them engaged and logged into our application as long as possible. Today, on day 2, we will see how to use an LLM to extract entities from the user's text messages. For example, we might extract a topic, the user's interests, or their recent sentiment. Remember, on day 1 we prepared a VLLM server to serve GPT-OSS 20B. We'll start using it today. We'll prompt the LLM to return JSON output. Since the model is relatively small, we may need to do a lot of prompt engineering to make it behave the way we want. Time to get started. I should mention that I implemented day 2 on the same day as day 1. Day 1 was done in the morning, around noon, and day 2 was coded in the evening. It's a Saturday, and since I'll be working on this project alongside my full-time job, I want to make the most of the weekend. I'll also record the time it takes, so we'll know the total effort for the whole application. I begin by uploading my plan into ChatGPT. Of course, this is just an orientation. Some tasks may take more time, others will be straightforward. So I prompt ChatGPT, I'm implementing an AI agent to track user interests. The goal is to simulate a social media world and propose content to users based on their interests. So far, I've completed day 1. I paste the implementation of day 1 so ChatGPT has the context in my previous work. This refreshes the conversation so it can assist me better. I also mentioned that the VLLM server is running locally, serving GPT-OSS 20B. And that I'm working inside a VS Code dev container. With that setup, I asked ChatGPT to provide the code for day 2. I wanted to update the Gradio interface to use a new function called chat_with_user instead of process_input. This function will be our entry point. I had it at the beginning but removed it. I think I'll bring this function back, and it should invoke process_input as well as other functions we'll implement later. For data extraction, I want a function called extract_data to use the OpenAI API to send requests to VLLM. The LLM GPT-OSS 20B should extract entities, but which ones? Well, let's ask ChatGPT to propose a list of entities relevant for building this application. It's also important that the LLM returns JSON, because we want to systematically reuse its output in other parts of the application. So ChatGPT can propose a list of 5 to 10 relevant entities for an application like this. I think this prompt is enough for now. Let's see the result. It proposed a plan for day 2. If you like the way ChatGPT answered, give this video a thumbs up. Then it proposed the code. We can see there's a new import, OpenAI. I copy it and paste it into my Jupyter notebook. I always put my imports at the top, so I have a clear overview of the libraries being used. Next, we have some variables, the OpenAI API key, currently set to empty. We don't need a key here because our server is running the LLM locally. If you don't have this set up, you can use a cloud provider or OpenAI directly to access LLM models. In that case, you'll need to specify your API key here. So just keep that in mind. I'll copy this part of the code and paste it into my Jupyter notebook. Now my OpenAI client is set up, with the base URL defined across the notebook. But until we change the dev container.json file, we won't be able to access the VLLM server inside the dev container at localhost. Inside a Docker dev container, localhost points to the container itself, not your host machine. To reach services running on the host, you use the Docker Bridge Gateway 172.17.0.1, or host.docker.internal on some setups, which represents the host from inside the container. As a workaround, I will directly put this address here. This is really just temporary until the next rebuild of the container. By the next rebuild, I will fix this properly and explain. Next, I'll copy the function extract_data that ChatGPT proposed and paste it into the Jupyter notebook. The function is supposed to return a JSON. We can also copy the function chat_with_user directly. I'll create a new code cell for that and paste it there. The prompt for our LLM is as follows: you are an information extractor for a social media simulation. Extract key entities from the following user input and return a JSON. Then we parse the user input, and the prompt includes the list of fields the JSON should contain, for instance, topic, interest, sentiment, and so on. Each field also has a type and description. This is part of the prompt and serves as context. Next, we invoke the LLM endpoint. But there's a problem here. The model name doesn't match the way we defined it in the VLLM server configuration. Let me quickly copy that name and paste it into the code. The temperature is set to 0.2. Temperature controls the randomness of the model's output. Lower values make responses more deterministic and focused, while higher values make them more creative and diverse. Setting it helps balance precision and creativity depending on the needs of the application. Then we hit another issue. JSON is not defined. We need to import it. I'll add it at the top of the notebook as well. The function chat_with_user currently invokes the guardrail to validate the user input, stores the output in the variable label, then extracts the user data and stores it in the variable entities. But we don't want it to work like this. We cannot call the LLM when the user enters something irrelevant. That's the whole purpose of the guardrail. So what we need to do is first check the output of the function process_input. If it contains the word irrelevant, then we break the process and don't call the LLM. I'll ask ChatGPT to update the code for this. First, let's change the entry point in Gradio to point to chat_with_user. Then I'll prompt ChatGPT, please update to only extract if the user input is relevant. Time to test it. I need to relaunch Gradio. Now let's ask for the weather in Berlin. As we know, this topic is not relevant for the application. We can see that the system blocked it. Now let's ask something relevant. This is the exciting part. How to create a post. It takes longer to process because this time the question is relevant and should trigger the LLM for entity extraction. And boom! It passed, and we have entities extracted. Nope. The function extract_data returned an error. The frontend is not perfect, but we can see the error. It failed to parse the JSON. This happens when JSON loads fails, which means the LLM didn't return a valid JSON. Let me copy the output and paste it somewhere else so we can better inspect the raw output. The LLM didn't just return JSON. It added extra formatting, like when you write documentation in Markdown and define a JSON block with 3 backticks, followed by the keyword JSON, and then close it with 3 backticks. But that's not what we need. We need JSON that is ready to use in Python code. So let's instruct the LLM to return that instead. I'm not entirely sure how to phrase this better. Maybe I should list the entities with hyphens? Let's try. We need to rerun. Gradio is loading. This time I'll ask a relevant question directly, since we already know the guardrail works. Click Submit. Again, failed to parse JSON. The LLM just returned the JSON in the same Markdown format as before. Let's undo the changes. Now I'll instruct it to return only valid JSON. Time to rerun the test. Gradio is loading. I ask the relevant question again. Same error, failed to parse JSON. Let's do more prompt engineering. This time I'll explicitly tell the LLM not to add special characters. I rerun everything. Gradio is loading. Let's retry with a relevant question. Again, failed to parse. I'll reduce the temperature now. It feels like the model is being too creative. Relaunch. And ask how to create a post. Same error. It keeps returning a markdown JSON. Now let me try again, but this time ask it to return JSON without extra formatting. And it works. We now have the LLM returning a proper Python JSON. We see the topic extracted, hashtags, and so on. Next step, we need to fix the frontend to better display the system output. This is a good task for ChatGPT. I'll copy my code and ask, please update Gradio to act as a chatbot and display the conversation history, not just the last input, answer pair. Here's the answer. We won't need everything, just the part with the Gradio interface. I copy only that section and paste it into my Jupyter notebook. Relaunch the interface. Ask again, how to start a post. And we get an error. We need to scroll down to see it. The function chat_with_user now expects 2 arguments. Let's double-check in ChatGPT. Okay, so now it also expects the history. Not sure, but let's give it a try. Copy, paste. Relaunch. It's loading. I'll open the link in a browser to see it better. Resize a bit. Ask, how to start a post. The question already appeared. And here it is. It looks much better now. We can see all the extracted entities at once. At the bottom, you can even refresh your question. So with this, we're technically done with day 2. But I still have some time, so I'll start preparing for day 3. I'll define a kind of database with users and their passwords. The first user is K-Tips with password pass123. The second user is Daniel with password pass456. Now let's ask GPT to use this and update the frontend so users first authenticate. I also want to add feedback buttons, like thumbs up and thumbs down, after each response, so users can rate the system's output. What I have in mind is to attach an ID to each question-answer pair and store it in the conversation history we defined. Let's move this variable to the first code cell where I keep my other global variables. Organization is key, guys. Later we'll refactor the whole code base, but for now let's just keep things structured. Now let's see what ChatGPT thinks about this. To achieve it, we need an auth gate on the frontend. We can do this with Gradio blocks. Nice. Then, if the login succeeds, we load the chatbot UI. Second step, attach an ID to each question-answer pair. Then add feedback buttons linked to the response ID. On click, the feedback should be stored in the conversation history. ChatGPT is still using localhost. I'll need to update its context, but that's not necessary for now. I won't copy the whole code anyway. Here it gets interesting. In the function chat_with_user, we can see this QA_ID line. It generates a unique UUID each time the function is invoked. That means each question-answer pair has its own ID. But we need to import the library. UUID is a built-in module that lets you generate universally unique identifiers, UUIDs. I'll copy and paste it at the top of my Jupyter notebook. That's how I like it, all my imports in one place. Now let's copy the updated chat_with_user function. This function now returns not only the system reply, but also a feedback UI, a Gradio row with 2 buttons, thumbs up and thumbs down, plus an element ID attached to the generated question-answer ID. I think this might do the trick. Let's update our code. We also need to move the Gradio import to the top of the notebook. Double checking. Okay, now we need two additional functions, record_feedback and login. Record_feedback expects the question, answer pair and the button value as parameters. This function is triggered when the user clicks one of the feedback buttons. It updates the conversation history by adding a feedback field with the corresponding value. Then it simply returns a message saying the feedback has been recorded. Remember, our conversation history is still a global variable in the notebook, so this setup works fine for now. Login expects a username and password. It then checks if the password matches one of the mock database users. If correct, it updates the frontend. Straightforward enough. Now let's copy the updated interface. I can tweak this comment here. Okay, that's a lot of changes. To make sure everything works properly, I'll clear all notebook outputs, restart the kernel, and run all cells from scratch. Checking while it runs. And boom! We now see the login gate first. Let's open it in a browser. Refresh. No interface is running right now because we restarted the kernel and reran the Gradio interface. Let's grab the new link. Here's the welcome page. It asks for username and password, has a login button, and a text box showing the login status. We currently have 2 users in the database. Let's try with K-tips. By the way, do you enjoy this video? Then like and subscribe for more. I log in as K-tips, and boom, the chatbot appears. I don't love the layout, but let's test it anyway. I ask, how to start a post. We get the system output, but wait, where are the feedback buttons? They're supposed to appear after the reply, but they're missing. Let's try an irrelevant question, weather in Berlin. The guardrail blocks it as expected. But now, where are the feedback buttons? Time to ask ChatGPT why they're not showing up. Double checking. The code does include them. It's already 6:55 p.m. Technically, day 2 is done, but I'm still debugging, kind of warming up for day 3. Let's check ChatGPT's answer about the feedback buttons. I copy the function chat_with_user again and compare. Let's also copy, paste the Gradio interface once more and rerun it. Honestly, I'm a bit tired now and don't want to overthink. So I log in directly inside the notebook. And boom, now the feedback buttons appear. Whatever. Let's ask a question. Looks good. Now let's click on a feedback button to see if the conversation history updates. We hit an error. Type error. String indices must be integers, not strings. This happens inside the record_feedback function. Double checking. We don't actually need to update this in process_input anymore. Here's the problem. We're trying to access the ID key, but we initialize the variable as a list. I'll change the initialization to none. Let's run all cells again. That should fix it. I think the issue also came from not rerunning the very first code cell. In earlier executions, the conversation history variable was still a list, but now we're accessing its elements as a dictionary. Now let's improve the front-end layout. I'll ask ChatGPT, please put the input box on a new line, same for clear chat, and also remove the login fields once the user successfully authenticates. While it's thinking, let's quickly test the app. I ask a relevant question, how to create a post. And we get an error. Let's scroll down and check. We hit another error, attribute error, none type, object has no attribute, append. Alright, time to fix the initialization of the conversation history again. I'll reset it, maybe to an empty dictionary, or better, an empty list. Then rerun all cells. Next, I'll copy the Gradio code that ChatGPT proposed and paste it in, just to test directly. We need to relaunch the interface. Log in again. And boom, another error. The login function didn't return enough output values. Let's check what the login function actually returns in ChatGPT's version. It returns one Gradio update setting a component to invisible, and another Gradio update setting another component to visible. Okay, let's copy-paste that, and rerun. It's loading. Now let's log in. Same problem again. I'll paste this error message back into ChatGPT. Testing its fix. Frontend is loading again. Let's log in. Yes. Much better now. No login gate anymore after authentication. Each component of the chatbot is nicely on its own line. Let's test with weather in Berlin. Guardrail blocked it, no entities extracted. Now how to create a post? Excellent, it passed the guardrail. LLM call was successful. And the feedback buttons are here. Let's give it a thumbs up. By the way, thumbs up, what do you think about this challenge? If you like it, give this video a like and leave a comment. After clicking thumbs up, I see the message, feedback recorded, up. Now thumbs down, it updates to feedback recorded, down. Perfect. Now let's check the conversation history. For the first question, weather in Berlin, we have an ID, the user input, the system reply, and none for the feedback. Makes sense, because we didn't give feedback there. For the question how to start a post, we've got all fields filled, including the last recorded feedback, down. It's 7:12 p.m. Good time to wrap this session. Our goal today was to extract user entities from input text. And we did it. But not only that. On day 1, we built the entry point where users provide input, and set up a guardrail to classify it. If you missed that video, check the link appearing now. I'll also leave it in the description below. Today, day 2, was about extracting entities from relevant inputs. And you can see, it works really well. We're extracting topics, user interests, sentiment, hashtags, and more. We also fine-tuned the prompt so the LLM returns valid JSON-only, which makes it directly usable in our Python code. On top of that, we warmed up for day 3. Remember the mock database we created, with 2 hard-coded users and their passwords? That's fine for testing, but you'd never do this in production. So tomorrow we'll set up a real MySQL database for user profiles. And also a Milvus vector database to handle conversation history and embeddings, since that can grow very quickly. So day 3 will be about setting up MySQL for users. setting up Milvus for vectors, writing the logic to insert new user records, and learning how to query all this data. The project is getting serious. Of course, some parts are still improvisation, like this Gradio frontend, but it works surprisingly well so far. And the best part? The conversation history now records feedback properly. When I click thumbs down, it stores down. When I switch to thumbs up, it updates to up. That's very nice. And with that, we can wrap up this session. If you found this video helpful, don't forget to like, share, and drop a comment. Also, subscribe so we can tackle day 3 together. See you in the next one. And as always, happy coding, and happy debugging with K-Tips.